Today we're going to talk about two things. The first is the greatest integer function. The greatest integer function, whose symbol is what we might call a double-backed bracket with x or whatever inside, double-back bracket. The greatest integer function is defined as the greatest or largest integer that is still less than or equal to x. So there are important things in here. It has to be less than or equal to x, and it is an integer. So we're not using um, fractions or decimals as our answers to a greatest integer function problem. So I put a number line out here, and I like to think about the greatest integer function as kind of a one-way intersection, a one-way road where we're going forward. And the integers represent gas stations. And so the greatest integer function is asking you, where will you go to find gas if your car runs out of gas? So the greatest integer function of 2. So what is the greatest integer that is less than or equal to 2? Well, if my car stopped right here and the gas stations are at all the integers, I'm going to go out of my car, say a small word of thank you, and put gas in my car right at 2. The greatest integer function of -3. Okay, so if my car stopped at -3, I'm going to say, yay, yippee, because I'm right at a gas station, right at an integer, so -3. So not very interesting if I put an integer into the greatest integer function. So integer in, same integer back out. It is much more interesting if we put something that is not an integer into the greatest integer function. So not an integer, like 1.98. So my car stops at 1.98. Now one would think that since I'm closest to 2, I would go to my gas station at 2. However, that is not true. The greatest integer function says I'm going to go to the one that is less than, since it's not equal to, less than. So where is that integer? That integer is back here at 1. Another way to think about it is if my car stops at 1.98, I know that I've passed a gas station at 1. I do not know that there is a gas station at 2 because I have come kind of down the road to here, and all I know about is all the things I've passed, not anything I have come to yet. All right, similarly, let's take this out. Let's suppose I run out of gas at -1.98. So -1.98 back here. Where am I going to get gas? Well, if I've driven along to here and my car stops, the integer that is less than where I am is -2. So -2. Okay, what does the graph of the greatest integer function look like? Well, I should probably put some grid paper out here instead. That'll be neater. Okay. So if I have f of x is equal to the greatest integer function of x. Okay, if x is 0, that's an integer. If x is 0.1, 0.2, 0.3, 0.4, 0.5, up to 0.99999, right? It's still going to be 0 until I get to 1. If I put 1 in here, it's going to say, no, I'm 1. 1 is an integer. But if I'm 1.1, 1.2, 1.3, it's still going to say 1 until I get to 2. And then it's going to say, no, no, I'm 2. I'm an integer. And up to 3. And then 3 is going to say, no, I am 3. I am an integer. So like this. If I'm -1 up to 0, it's still going to say -1 like this. So some people call this the step function because it looks like steps. Its formal name is the greatest integer function. Today's lesson also includes graphing a piecewise function. So we saw piecewise functions when we were analyzing them. Now we're going to graph a piecewise function. There are lots of techniques. I sometimes look at my turnaround points. So I have x's that are less than -3. So -3 is going to be a key location for me. Between -3 and 2, so 2 is a key location, and beyond 2. So I'm going to have 3 parts. Some people even like to put in little dotted lines to say, okay, this breaks it up into like a 3-paneled graph. So there's going to be a piece over here that looks like f of x equals 2. There's going to be a piece in here that looks like absolute value of x plus 1. And there's going to be a piece over here which looks like the square root of x minus 2. Alrighty. So the first piece, which is the x less than -3 piece. Okay, so for every x that's less than -3, the y value is 2. Okay, so the y value is 2. So that looks sort of like, and I want to come right up to -3. I don't want to just draw it so that there's this gap. At -3, if I could be there, I would be 2, but I can't be there. So I use just a little open circle. There, that's the first piece. Okay, between -3 and 2, so any value between -3 and 2, I'm going to plug into this piece, including -3 and 2. So -3 would be absolute value of -3, 3, plus 1, 4. -2, 2, plus 1, 3. -1, 1, plus 1, 2. 0, plus 1, 1. 1, plus 1, 2. 2, plus 1, 3. So in here, I'm getting my nice absolute value shape. And then beyond 2, so over here, x value is beyond 2, I plug in here. So 3 minus 2, 1, absolute, or square root of 1, 1. 4 minus 2, 2, square root of 2, ugly. 5 minus 2, 3, no. 6 minus 2, 4, square root of 4 is 2. So I'm getting this kind of look, right? But I don't want to leave a gap. So I am going to plug the 2 in. 2 minus 2, 0. Square root of 0 is 0. But since I can't actually be there, I should not have plugged it in. I'm going to use an open circle. So now I've got a very complete graph. It goes here until you get to here, and then you jump here until you get to here. And then we jump into the open circle, but we're not really there. And then we just follow it out of town.